All right, Math 1, graphing linear inequalities. So let's review what an inequality is. It's something that has a less than or a greater than sign, or it could have a less than or equal sign or a greater than or equal sign. Remember that previously we've been given problems like x is less than 5 or x is less than or equal to 5, and we would look at a number line, we'd find our 5. For the one on the left, just plain old less than, we'd have an open circle, then we'd shade, and the one on the right, we'd have a closed circle, and we would shade. So in this one, we're looking at lines now, right? That was like a one-dimensional idea. Now we're going to a two-dimensional idea. We have x and y. We're going to start off by just plain old graphing the line, okay? We can graph the line however we want. Normally, if it's in general form or standard form or slope-intercept form, I'm going to go ahead and graph it however it's listed, right? So this one here is in general form or standard form, whichever one you want to call it. So we can get our x-intercept and our y-intercept really quick. Our y-intercept, we plug in 0 for x and we get this thing just kind of hides. So y is going to be -4, right? We divide by that negative. And then for our x-intercept, we hide our y, and x is going to be 4/3. So I'm going to put dots on the x is 4/3 and y is -4. And now we need to draw our line. So whenever we draw our line, we need to look and see, is this a less than or is it a less than or equal to? If there's no equal to bar, then it's going to be a dotted line, right? So I'm going to have a dotted line here. And again, lines have arrows, so we need to have arrows. Next up, we pick a point to plug in. Normally I pick 0, 0. The only time you cannot pick 0, 0 is if your line actually touches 0, 0, okay? So if it touches 0, 0, you're going to need to pick like -1, 0 or any other point really. So I'm going to plug in 0, 0. I'm going to have, well, 3 times 0 minus 0 is less than 4. Well, this is 0 minus 0 is less than 4. 0 is less than 4. That's a true statement, so I'm going to shade towards 0. So I like to draw little arrows and then shade. It kind of helps me understand what I'm actually doing here. I'll use the highlighter to shade. I think the arrows are valuable because later on we're going to end up doing two different lines, and sometimes it's hard to see how do we shade. Now, like I'm doing it on my iPad, I have different colors. If you guys are all doing it in pencil, then it's kind of hard to see, well, did I shade this and this, different things like that. I think the arrows are a good thing to use, so that's why I use them. All right, number 2. We need to first graph this line. We're going to kind of like pretend like there's an equal sign there and graph it that way. This is in slope-intercept form, so m, our slope, is 3/4. B, our y-intercept, is 5. So I'm going to start off putting a dot on our y-intercept, and then I'm going to make our slope. I go down 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Right. Now we need to draw our line. It's a dotted line. It's a dotted line because there's no equals to. If this was less than or equals to, we'd do a solid line. But because it doesn't have that little bar there, it's a dotted line. Again, we're going to plug in 0, 0. So I'm going to say, well, 0 is less than 3/4 times 0 plus 5. Well, this is the same thing as 0 is less than 5, which is a true statement. Hopefully we all know that that's a true statement. So I'm going to shade towards 0, 0. Right? All right. There's 1 and 2. Let's look at number 3. We have another line that is in slope-intercept form, so I'm going to start off by putting a dot on the -5 because that's where our y-intercept is. And then I'm going to go up 5 and left 4. So up 5 would put me here. Left 4 would put me here. right? We can see really quickly that that's going to have a negative slope, which is what we want because it does have a negative slope. We look at our greater than or equal to sign, and it says equal to, so it's going to be a solid line. All right, so it's a solid line, and we now need to pick a point. We're going to pick the point 0, 0, and I'm going to plug that in. So I'm going to say, well, 0 is greater than or equal to negative 5 over 4 times 0 minus 5. Well, that's the same thing as 0 is greater than or equal to negative 5, and that is a true statement. So we're going to shade towards 0, 0, just like that. All right, last one, number 4. Now, if you remember, whenever we have something in standard form like this, we can't plain old graph the intercepts because there's a 0. So I'm going to have to rearrange this to say, well, y is less than negative x, right? I subtracted my x to the other side. So that tells me that my b is 0 and my slope m is negative 1. So here's my dot, and there's my slope dots. It's just the plain old less than, so I need to have a dotted line. And I need to pick a point. Now this one, I'm going to pick the point 1, 1. Because it's on 0, so I can't use 0. So if I plug in 1, 1, I'm going to plug into the original equation. So I'm going to say 1 plus 1 is less than 0. Well, 2 is less than 0. Well, that's not true. So I'm going to shade away from it. I shade over here. All right.